In this video, I'm going to talk about a procedure in Statgraphics for comparing regression lines. What this procedure does is it goes in and fits a linear regression model, allowing the intercepts and the slopes to be different for each level of a categorical factor. Now, the usual equation for a straight line is y equals mx plus b, where m is the slope and b is the y-intercept. What the procedure will do is it will actually fit separate regression lines of this form for each level of a categorical factor, and then let us go in and test whether or not there are significant differences amongst the intercepts or the slopes by levels of that categorical factor. To demonstrate the procedure, I've loaded up a data set that has to do with manufacturing soap. The data is taken from two different production lines, line 1 and line 2, and experiments have been made running both of these lines at different speeds. The variable of interest is in a column called scrap, and what we want to know is how the amount of scrap varies with line speed, and whether or not there's a significant difference between line 1 and line 2. To fit the model, I'm going to go up to the top menu to Relate, One Factor, Comparison of Regression Lines. On the Data Input dialog box, I'm going to specify scrap as the dependent variable, what I want to predict, speed as the independent variable, and line as the variable with the level codes. Now, there are only two lines. That's not a requirement. There could have been several different lines. I'm just trying to keep the example simple, so I just have data from two lines. The next dialog box will ask whether I want to assume equal intercepts or assume equal slopes. For now, I won't assume either. I'll just press the OK button. It'll then offer me several tables and graphs. I'll take the defaults, at which point the analysis window will open. To examine the output, let's double-click in the upper right. Here you see the plot of the fitted model. There's a regression line for line 1, a regression line for line 2. Now, the amount of scrap appears to change quite dramatically with line speed. The slopes of both of those lines are pretty steep. As far as the differences between line 1 and line 2, line 1 appears to have a somewhat higher amount of scrap. That would be a difference between the intercepts. And line 2, its regression line appears as if it might be just a little steeper than line 1. Question, are those differences statistically significant? Well, to find out, we can go down to the bottom left to what's called the further ANOVA, further analysis of variance. What this will do is this will calculate three p-values. A p-value for speed, a p-value for differences amongst the intercepts, and a p-value for differences amongst the slopes. Small p-values correspond to significant effects. In this case, the regression against speed is highly significant, very small p-value. The intercepts also appear to be significantly different. That p-value is also very small. However, the slopes do not appear to be significantly different. Their p-value is well above 0.05, even 0.10. So it appears that if, in fact, the slopes might be the same, they're not significantly different for line 1 and line 2. Now, at that point, I can go back to the regression model, press the right mouse button, go to Analysis Options, and tell it to assume equal slopes. It's now fit two parallel regression lines, assuming the slope is the same for both lines. If you want to see the underlying equations, you can put the graph away and go click in the upper left-hand corner. Here you'll see the statistical output, and if you scroll down a ways, you'll see the Stat Advisor. Now the Stat Advisor will show you the fitted mathematical model. In this case, scrap is equal to a constant plus some slope times speed minus another coefficient multiplying what's called an indicator variable. Here it's labeled line equals 2, which is either 1 if true or 0 if false. That amounts to the two separate regression models that you see below, one for line 1 and one for line 2. You can see they have the same slope but different intercepts. Very handy procedure when you want to fit several regression models by level of a categorical factor and test for significant differences.